welcome back to the workshop of robotics with Arduino. And yesterday we basically saw what are the different. I know what we initially started with the definition of robotics, and then we saw what are the different components which are basically required to build any robot in general. Okay, and then we saw about the sensors, about microcontrollers, and then about what are the general outputs of any robot, like motors, like actuators and stuff, right? And then we started exploring about the started discussions about the Arduino and why Arduino is important, and how we can basically program Arduino, and what are the different kinds of Arduinos available in the market. Okay, and then we saw how we can basically control one LED. Okay, and then we basically programmed our LED, which is actually interfaced here on our robotics kit. This is basically our follower robot kit. Okay, and we saw how we can basically generate any color if you are using RGB LED with the Arduino. Right. So this way, yesterday we saw how we can basically start our initial level or beginner level of project, like the control of LED, and generating and getting all the different possible colors by the programming and the hardware, right? So today we are going to see about the initially we will start this second day workshop with the introduction to the sensors. Like yesterday we saw about the definition of sensors, the importance of sensors, but today we are going to see what are the different types of sensors available, and how we are going to extract the data from those sensors, those different variables of variations of sensors through the Arduino. Okay, and then at last we will see how we can build a very basic or the our first robot. Okay, so that will be basically a object follower robot, where this robot, this particular robot which I have over here, this particular robot will actually follow any object, will be programmed. We will program this robot in such a way that this particular robot will actually follow any object in front of it. Okay, for example, like if there is someone, if there is any object in front of it, and so you can basically maneuver this robot just by the movement of your hand. Okay, so we are going to explore this domain of robotics in this 3-day workshop for sure. Okay, so this is basically the second day. So we are going to start with the sensors, and we will see how we can basically extract the data from the sensor with the help of Arduino. Okay, so first of all, yesterday we discussed about the sensors, and we discussed that sensors are basically one of the most crucial components to build any robots, especially when you want your robot to be autonomous, right? Because in the definition of robotics, we saw that robots are those machines which are autonomous and which can basically sense the environment where it is available or not. Okay, so for that we require some sensors. Now in general there are two different kinds of sensors. The first you can say are the digital sensors, and the second one is the analog sensors. Okay, so in digital, the value which you get from the sensors are basically in binary. Okay, binary basically represents only two numbers. Either it will give you the data in terms of 0 or false, or either it will give you the data in terms of 1 or 2. Okay, so basically 0 represents 0 voltage in general. Okay, in all cases, in fact. Okay, and 1 in general represents 5 volt, but in some cases 1 also represents 3.3 volt, basically, which means that if you are getting 1, it will send the data to the Arduino as a 5 volt. Okay, and similarly, as if it is giving you 0, then it is going to give you the 0 volt. If you have a multimeter, any kind of multimeter, so even a voltmeter, so you can check the voltage across that particular pin. Okay, and on the same way that the analog sensors are basically those kinds of sensors which basically has the. Okay, so analog sensors are those kinds of sensors which basically gives you the data in continuous form. Okay, in digital it gives you the data either 0 or 1, but in analog it gives you the data in continuous form, which actually depends upon the analog to digital converter bit. Okay, the ADC bit which a microcontroller has. what ADC is, how do we define ADC, and all those terms. We will try to explore in some other workshops where we will focus on intermediate level of workshops. Okay, so this is our focus will be on the beginner level, so that we can encourage more and more students to pursue robotics as a career. Okay, so this is the basic idea. And so the analog sensors give you the data in continuous form. And in Arduino, in any Arduino in general, it does, for example, if you have Arduino Nano like this, okay, or if you have a Arduino Uno or Arduino Pro Mini, so in general there are 10 bits of ADC in any Arduino. Okay, so 10 bits of ADC basically means that it is going to give you the data in continuous form with a range of 2 zeros to 2 to the power 10. Okay, which will give you the data from 0 to 1024. Okay, so your value will basically vary from 0 to 1024. Let me just give you a very quick example of digital and analog sensors. For example, here you can see that these are the IR sensors over here. Okay, so these IR sensors, first of all, let me just tell you, these IR sensors basically detect the presence of any object in front of it. Here you can see that these are the IR sensors, this one and this one. Okay, and here you can see there is a black LED and there is a transparent or white LED over here. Okay, so this IR sensor, as the name suggests, infrared sensors transmit the infrared rays. Okay, infrared light or infrared rays from the transmitter, this white LED, and whenever it detects any object in front of it, and no matter what object, if it detects any object in front of it, the rays are being reflected by that object and it is received by this receiver. Okay, so this black LED is basically the IR receiver. Okay, so and then it gives you the data. So that is the only reason we are going to use IR sensors for our project in terms of object follower. So whenever it will detect this, so our bot will move in the right direction, right? And whenever it will detect if it detects any object in the left IR sensor, so our bot is going to move in the left direction, right? And if any if both the IR sensor detect any object in front of it, so our bot will move in the forward direction. We will see how we are going to program this robot step by step. Okay, but initially we will start with the sensors only, and we will see how we can basically get the data from sensors. Okay, so these are basically the IR sensors which gives you the data in digital form. Okay, so hence they are called digital sensors. And apart from that, there are some other sensors also. For example, there are here you can see that there are two light sensors, or technically they are called LDR, basically light dependent resistor. Okay, and as the name suggests that the resistance of this sensor basically varies with the intensity of light falling on it. Okay, so these are two LDR which we can program in such a way that this robot will basically follow the light. Let us suppose that in this room, if we dim the light a little bit and if we turn on the torch or if we turn on any source of light, okay, so we can basically maneuver this robot just by focusing, or just by we can basically change the direction of this robot or maneuver this robot by by the light which we have. Okay, we can basically control the direction of this robot by the light. Okay, so this can also be programmed as a light follower robot. Okay, so let's start with the first of all we will see how we can get the data from digital sensors, and then we will see how we can basically get the data from the analog sensors. Okay, so for digital sensors we are going to get the data from the IR, and for analog sensors we are going to get the data from LDR, or light dependent resistor. Okay, so for that let me just start with the Arduino IDE, and then we will see how this IR sensors are basically giving us the data. Okay, this is here we have as yesterday also we discussed that whenever you will start a new project on Arduino IDE, you will see that there are already two inbuilt functions. The first is the void setup, where we initialize, where we declare that our components, our devices are going to be used as input, or they are going to be used as output. Okay, and in loop we write all the main algorithm, we write all the main programs, that how those this how this a microcontroller, how this project is going to be executed, and what logical decisions your machines are supposed to take with certain inputs from the sensors or from the users also. Okay, so initially what we want is we want to get the data from the IR sensor, which is basically a digital sensor. Okay, so there are two IR sensors here in our robot. So let us say if we initialize first IR sensor, which is connected in our robotic kit at the digital pin number 12. Okay, so let's declare this as integer. See, the IR one is basically the variable which is declared as integer over here. Okay, and now in the void setup mode, what we are going to need is we are going to initialize this IR1 as input, right? Because yesterday also I have said that all the sensors are supposed to be as are supposed to work as input. Okay, and then again serial dot begin 9600 for the baud rate. Okay, so here we have basically initialized the baud rate. Okay, now in the void loop what we are going to need is first of all we have to like read the digital value of IR sensors. Okay, what is the digital value? Either it is 0 or either it is 1, and let us say that we want to store this value sensor 1 in the variable called sensor 1, and now we are going to need to declare that variable as integer. Okay, so first of all what we did, first of all we have initialized the number, the pin at which your sensor is connected, and here in our kit IR sensor is basically connected at the pin 12 of this robotic kit. Then we declare that our IR sensor is basically going to be going to work as input to this microcontroller. Okay, and then in the void loop function, in the loop function we basically saw that first of all we have written this line for to get the data from the digital read. Okay, it will get it will basically fetch the digital data from the IR sensor, and then it will store that particular data in the sensor one variable, which is basically the integer. Okay, and now what do we need is we need to print that data, right? So serial dot print, and serial.print basically will print your data. So here we can in the semicolon and in this inverted comma over here, so we can basically in the parenthesis and in the inverted comma we can basically write anything which will be printed as it is. For example, let's say digital value of IR is. Okay, so it is going to print this value as it is, and then serial dot print, sorry, ln. Okay, and here we are going to print the sensor one value. Okay, because we have stored the value of IR sensor, the digital data of IR sensor in the variable called sensor one. Okay, and then let's give a delay of like 200 milliseconds. Okay, so remember this, that this is basically the value of this value inside the parenthesis of delay function is in milliseconds and not in seconds. Okay, so this is the code for the IR sensor, and this is it. So let me just connect my my kit with the USB to with my computer, and now it is connected, and now I'm going to upload this program. So initially what we are supposed to do is, we are going to first of all verify this code and see. For that you have to basically store this. Okay, so let's write that I'm going to store this on digital read, a file name. Okay, here you can see that the okay, so it is compiling the code. Yeah, and here you can see that the code has been done compiling. Okay, now we need to go to the tools and select our Arduino Nano because we are using Arduino Nano, right? And then on the processor at Mega 328 bootloader, and on the port COM8. The port can vary at the with your computer. So select the port where you have connected your Arduino. Okay, not necessarily it will always be on port 8. Okay, all right. So let's upload this code by clicking on this arrow button, and here you can see that the code has been uploaded. Okay, so this our IR sensor is basically connected at the pin 2, not on 12. Okay, so let me just upload this again. All right, and now let me open this serial monitor. Okay, so in the serial monitor, let me just share that screen with everyone. Okay, so now in the serial monitor, you can see that the yeah, I hope you all can see this. Can anyone write down in the chat section what you can see in the serial monitor after the digital value of IR sensor is? Okay, so the value is basically 1, right? Sorry. Okay, so here you can see that the value of the IR sensor is basically 1. Now let's focus on this bot over here. Okay. Now let's focus on this bot over here, and when I will bring my hand in front of this bot, you will notice that the value of IR sensor will change. Okay. Can all of you confirm this? Can anyone confirm this on the chat section that yes, the value of IR sensor is basically changing? Okay, so let me just get this one. Okay, here, and here you can see that whenever I'm going to change, bring my hand in front of it, there are two things which you can notice. The first thing is that here you will notice that one LED actually turns up. Okay, and the value of our IR sensor basically changes to the let me just make it like this. Okay, so that it becomes more clear to everyone. Yeah. Okay. So the moment when I bring my hand in front of this, so you can see that the value of our IR sensor is basically changing to 0 from 1. Okay. So we are going to use this, the change in the digital data to program our robot in just few minutes. Okay. So let me just stop sharing this screen. Okay. So, is there any doubt about this thing, that how this particular IR sensor is working as a digital sensor, or how we have programmed this thing? If there is any doubt, so feel free to ask. Okay. If there is no doubt, so you can also write down in the chat section that there is no doubt. Okay. Okay. Thank you. All right. So, okay, so let's see another code, another thing that now we have just saw how we can basically get the data from the IR sensor, right? Now it's time to see how we can get the data from these kinds of digital sensors. For example, these sensors over here, these are basically the LDR sensors. Okay, let me just put this on a stand or something like this, so that this becomes more visible to all of you. Yeah, I guess this is more visible to everyone now. Yeah, okay. Alright, so here you can see that there are two IR sensor. The one is over here and the other one is this one. Okay, so let me just share this screen with you about the same Arduino code. Okay, so here you can see that initially we saw how we can basically get the data from the digital sensor. Now we are going to get the data from the analog sensor. So let's write LDR1 because there are two LDR sensors, and first of all we have to initialize the pin at which our LDR sensor is connected. So the LDR is basically connected at the A7 pin over here. Okay, and then let's write this as LDR1 because it is, and it is definitely going to be input. And here also if you want you can write the sensor 1, okay, that is not a problem, but change this to the LDR1 and change this digital read to the analog read. Right now because we are going to get the data from the analog sensor. Okay, so let's change this also as analog value of LDR is sensor 1. Okay, so this is done. I guess let's upload this code on the Arduino Nano. Okay, and similarly let's go to the serial monitor which we have over here. Okay, can anyone write down okay, so let me first of all share this thing on this screen. Okay, so that you all can see the data which I am getting from the Arduino actually. Okay, so can you all see this white screen on your Arduino on your screen now? I hope this is visible to everyone. Okay. Okay, so let me just make this a little bit bigger. All right. So yeah. So here we have two LDR sensors, but we have basically programmed one LDR. Can anyone write down in the chat what is the value you are getting? The values are basically changing, but yeah, okay, so the value are basically around the 760, 750 or 745. Yeah, so the value is basically changing, but see the thing is that please feel, notice this, that right now the amount of light falling on these LDR sensors are actually in most way is actually constant. Okay, but now what I'm going to do is I'm going to block the amount of light falling on it, and for that I'm going you can actually use I can basically use my hand. Okay, and can anyone let me know in the chat section that what is the value you are getting now, and after, when I remove my hand, is there any difference over there or not, and what is the basic difference you are getting? For example, if I put my a paper on the top, what is the value you are getting? It's around 530, 540, right? And when I remove my paper, it's around it's more than 750. And when I try to block the amount of light falling on it by my hand, the value basically goes below 300. Okay, because my still there are some lights reaching to the LDR by the reflection through the table, right? Yeah, the values are reducing. Okay, so in this way what we can do is we can basically uh, okay, yeah, so see the thing is in this way we can basically I don't know change the value of analog sensors. For example, like here you can see that the value of your IR sensors is right now around 700. Okay, and now I'm blocking this light, so here you can see now the value is less than 320. Okay, it's around 315 or 310. Okay, so in this way, since we are getting the data from this sensor, so we can program this robot in such a way that the when the value of the sensors, when the value of the sensors are changing, it may decrease or it may increase, the robot should move in the particular direction. Okay, so all right, let me just stop this. Okay, so now if there is any question about sensors or types of sensors, like how we are going to use analog data or how we are going to use digital data, so feel free to ask, or then we can basically move to the programming of our first robot, which is the object follower robot. Yeah. So if there is any question, so do write that in the chat section, and if there is no question, so please write down no also. Okay. Okay, so let's start a new program. Okay, let me just share this screen with you all. Over here. Yeah. Uh, I hope you all can see this. This is basically a new project which I have just opened by the going to the file and new. Okay. So now I'm going to start a project called object follower. Okay, so first of all, let's write down in the top line on the first line, object follower robot. Okay, these two backslashes are used in almost all programming languages as comment lines or the comment section, where you can basically write anything, and your processor, your compiler will not check that. Okay, so you can write anything you want as a document. Okay, so let us initialize. Okay, so now we are going to program this robot as an object follower robot. So for that, first of all, let us initialize the sensors which we are going to use. Okay, so we are going to use two IR sensors, right? So first of all, let's write IR1, which is basically connected at the second pin, and then write IR2, which is basically connected at the third pin. Okay, you can connect it at whatever pin you like. You can either connect it on the digital, as well as you can also connect it on the analog pins also. Because in Arduino, you can basically use your analog pins as digital pins too. Okay, so these are basically the IR1 and the IR2. Now what we are going to need is we are going to initialize the motor driver. Okay, so first of all, let me just tell you about this motor driver thing, motor driver IC. First of all, why do we need any motor driver IC? For example, like in this board over here in our kit, you will notice that there is this IC, this chip over here. Okay, so this is basically a motor driver IC, which is basically a L293D. Okay, so the thing is, why do we need a motor driver? So see, the thing is that most of you must have read in schools even. Okay, that motors are run on your power, right? On the electrical power. Okay, and electrical power is basically the product of the voltage as well as the current, right? So power equals to voltage multiplies by the current. Okay, so Arduino is capable of delivering that amount of voltage. Arduino can give you 5 volt. Okay, which is not actually what motor requires. Okay, our motor requires more voltage than that, but you can basically give voltage from the battery, from the outer source also. But the thing is that motor requires at least 300 or 400 milliampere of current, but your Arduino can give you a lesser much less amount of current, that is around, I guess, 40 microampere or 40 milliampere. I'm just a little bit confused between micro or milliampere. Okay, but that is actually much more lower than your any motor, any DC motor. For example, DC motors like this, these are basically called the bow motors or the DC geared motors. Okay, so these kinds of DC geared motors are basically going to need at least 300 400 milliamperes of current, and for to run like in full throttle, it requires at least 12 volt. Okay, so we have programmed, we have basically designed this robot in such a way that the that our motor is getting 12 volt from the battery. Okay, so we are using three 18650 battery, which is basically below this a kit over here, below the board over here. Okay, so we are getting the amount of voltage we need, but the amount of current we are going to need, we have to extract from the Arduino. But Arduino is giving us very less amount of current. Okay, and motor requires much more amount of current than it is receiving. So there is a gap over there. So we need a bridge so that the amount of current it is receiving, it should be able to amplify that amount of current, and so that the motor can run efficiently. Okay, so that is the only reason we use a motor driver IC, because motor driver IC amplifies the amount of current it is receiving, which makes the amount, which makes the total power sufficient for your motors. Okay, so that is why basically you will are going to need motor driver IC in any project, in any robotics project if you are working. Okay, so there are different kinds of motor driver ICs available in the market, but in most cases L293D or ULN2803 motor driver ICs are used. Okay, so this is actually one of the most important components which you are going to need in to build your robot. So that's why I stopped the sharing of code so that we can discuss about this. Okay, so now let's go back to this. Okay, so I hope you all can see this this screen over here, right? Is the screen visible to everyone? Let me just check. Okay, all right. So here, initially what we have done is we have initialized the value of IR sensor, which is basically connected at our with our Arduino board. Okay, and now what we are going to need is we are going to initialize those same things with the motor pins also. Okay, so there are going to be two motors, but there are basically four pins with two pins with each motor. Okay, so then there are going to be four pins. So and I'm going to write it in this way. So motor one is going to be on is connected basically on pin number 5. Let's just copy paste this so that we can save some time over here. Okay, so motor 1, 2, 3, 4, which are connected at the pin number 5, 4, 6, 7. Okay, so these are the pins it is connected. Okay, and in this motor driver IC there are two special pins actually, which are basically called the enable pins. So one enable pin is basically connected at the pin 10, and the other one is actually connected at the pin 9. So why do we need enable pins? Okay, so enable pins are basically used to control the RPM of your motor. Okay, if you do not use enable pins, this is going to, your motor is basically going to run in full throttle or in full power. Okay, so these pins are used for RPM, or we can also write that these pins are used to control the RPM of DC motor. Okay, so this is done. Now let's go to the void setup mode. Okay, and here we have to initialize all these pins as input output input output. Okay, so for that we always use a function called this is basically a inbuilt function, which is the pin mode. Okay, so let's initialize first of all IR1. IR1 is our input. Okay, every sensor will always be used as the input. Okay, so there should be no confusion about this thing. All the sensors are going to be used as inputs all the time. Okay, let's copy this so that we can again save some time. Okay, from IR1 to, let's make this IR2. Okay, and similarly for motor driver also, let's write down here motor 1, which is basically the output. Okay, because these are actually the actuators, right? So write down the same line for motor 1, 2, 3 and 4. Okay, and same thing will go for the enable pins also. So let's write down here E and A. These are basically the variables. You can name whatever you want. Okay, but the variable names are supposed to be in such a way that you can understand what you are trying to initialize or how you are going to use. Otherwise it is going to be very much complicated. Now the serial dot begin 9600. Most of the statements, most of the lines in the code are actually going to be repeated in all the time. Okay, so this is basically the baud rate. Okay, so this is done. Now the important thing is our loop function. Okay, which is over here, void loop. Here we are going to write down our the main algorithm. And here what we earlier observed with the IR sensor is that when there is nothing in front of the IR sensor, it gives us the data or the value of 1, which basically means high. Okay, so first of all what we are going to read is digital read of like IR1, right? First of all we are going to read IR1, and let's store this in a variable, in the integer variable called status sensor. Okay, which basically gives us the status of the sensor, either it is 0 or 1, right? And similarly let's just write the same thing for the IR sensor 2 also. Okay, so now what we are going to do is we are going to program this in such a way that what happens if one of the IR sensor is high, or what happens if one of the IR sensor is low. Remember this, that when IR sensor detects any object in front of it, it will give you the low data. Okay, so we are going to use conditional statement like if else statement. So let us see, let's just copy this thing, okay, so that we don't have to write this again and again. Okay, so if status sensor 1 is going to be high, and let's say and basically represent the and operation over here. Okay, and let's say this is also high, means the IR sensor 1 is high, and IR sensor 2 is also high, which basically means that there is nothing in front of any of the IR sensor. So what we are going to do is we are going to keep this robot at rest. Okay, so this our robot should not move anywhere, right? It should not go anywhere. So let's give the command of low to all the motor pins. Okay, sorry, yeah, for the motor 1, similarly for motor 2, for 3 and for 4. Okay, so this is done for one statement. Now what we are going to need is we have basically we have to write this for 4 statements over here. Okay, so you can, what you can basically do is you can write down that now that what if both the IR sensors are detect any object in front of it. So what do we want is we want our robot to go forward, right? Because both these sensors are detecting the presence of any object in front of it. So this is done now. Now let's see that if only one IR sensor detects, let's say if IR sensor 1 if IR sensor 2 detects any object in front of it, so what should happen? It should basically go to the left direction. Okay, now let's make this one low. If IR sensor 1 detects something, so it should go in the right direction. For some of you this might look a little bit complicated, but when you will basically start writing this code, this is actually pretty easy. Okay, so I guess now the code is done. Okay, now let me just verify this. I'm just going to save this on the desktop as object follower robot. Okay, so as OFR. Okay, so it is done compiling. Now let me just upload this code. Okay, so the code has been uploaded. Now let me just turn on my other camera, and now we do not need to see this code again. Okay, so let me just turn on my other camera, and then we will see how this thing is basically working. Connected it with the adapter, and so initially what we are going to do is we are going to let me just fix this on this stand. Okay, let's go with this one over here. So what we are going to do is, first of all, we are going to basically see if this I know detects the presence of objects in front of it properly or not. Let me just fix this. Yeah. Okay. So now let me just use that piece of paper again so that it does not get in near my hand. So when it detects the presence of, when this IR sensor, this particular IR sensor detects the any object is in front of it, this particular wheel is moving. Okay, so this bot will actually go over there, and if this particular IR sensor detects the presence of object in front of it, so your robot will basically move there. And let's say that both the objects detect any object in front of it. Okay, if both the IR sensor detects any object in front of it, so both the wheels will move forward, and hence your robot will basically move in the forward direction, and then you can actually control the direction of your robot. Okay, so is there any question about this, or if there is no question, so we are going to see this robot how this is going to move here on this table. Okay, if there is no question, so please write down in the chat section that there is no doubt or no question about this. This is our robot, and here we have connected this with the adapter, which is actually connected to the extension, which we would not have required if we had this battery powered. Okay, so now what we are going to do is, let's control this robot using this piece of paper. Okay, so you can see that how we can basically control this. Okay, so due to the wire, it is going to be a little bit messy, but so this way you can see that your robot can basically go in the forward direction. You can basically control the direction of your robot. Is this visible to all of you, or is there any doubt or any question about the working of this robot? So feel free to ask if you have any question in the chat section. Okay, you can ask anytime, but feel free to ask right now also. Yeah, so okay, so this was basically the demonstration of our first robot. We saw how we can basically program this, and how all the components are interfaced over here, and what are the different components which we basically need for this. Okay, so yeah, so let me just turn off this camera, and let's focus on this one. All right. Okay. All right. So we just build our first robot. Okay. Object follower robot are using Arduino Nano. We saw what are the different sensors we are going to need. For example, we needed two IR sensors so that we can tell the robot at which where it should move. Okay, so our robot can basically sense the environment using the IR sensor. It can get the data from IR sensor, and it can then take the decision from those with respect to those sensors, with respect to the data it is receiving from those sensors. Okay, so we saw what are the basic components this robot to design object follower robot we are going to need. Okay, so in general terms, we are going to need Arduino Nano for sure. We are going to need two IR sensors, and then one thing is actually very crucial, very important. That is actually the motor driver IC. So we needed one motor driver IC also, and then definitely we are going to need motors. Okay, so that our robot can actually move. Okay, so these are the basic components which we needed, and then we saw how we can basically program all those components, all those devices, and how we can basically create a logical algorithm so that our robot can take decision on its own. Okay, so this was not actually manually controlled or manually operated robot. This robot can basically detect any object in front of it through its IR sensor, and then it can take any logical decisions. Okay, so you can basically this particular robot can also be programmed. Let me just grab this. Yeah. So this particular robot can also be programmed as a line follower robot. Okay. And there are other features also. For example, like there are two LDR, so you can program this robot as a light follower robot. And then you can also tomorrow basically we will see how we can program this robot as a edge avoidance or as a cliff avoidance robot. Okay. We will see how we can build this, and then we will also see how we can basically program a remote controlled robot, okay, tomorrow. And then at last we will see how we can basically program a Bluetooth controlled robot, which is here over here. Okay, yesterday also I have mentioned that here you can see that this one is actually a Bluetooth module which is basically controlled on this connected with this Arduino Nano. So this board is actually as same as the earlier board, this one board. Okay, but this robot, this kit has basically a more feature than this robot. Okay, so basically this robot has lot more feature than this robot. Okay, robot, how these robots basically work, and how we can basically build these kinds of robots. Okay, so tomorrow at the same time, please join at the same time and with the same link. Okay. All right. So if there is any question, feel free to ask, or you can write down your questions for tomorrow also. Okay. All right. Have a good day. Okay.